This will be a follow-up video on an earlier video that I did where we verified trigonometric identities using the fundamental identities. Here, the only thing we're going to do extra is we're going to use properties of logarithms. So let's look at the first one. We have the natural log, that's understood to be base e, of the absolute value of 1 plus cosine x plus natural log of absolute value of 1 minus cosine x is equal to 2 natural log of absolute value of sine of x. And of course we're using absolute values here because the log of a negative is not defined. So the absolute values is simply to guarantee that we're not taking the natural log of a negative number. So we mentioned last time that in proving identities we normally start with the more complex side and simplify it to get the other side. So in this case, it's pretty straightforward that the left side has more terms, a little bit more complicated than the right side. So I'm going to take the left side, write out the natural log of 1 plus cosine of x, and that'll be plus the natural log of the absolute value of 1 minus cosine of x. And we're going to say this is equal to, and there's a property of log that tells you that if you have the sum of two logs to the same base, that's going to be the same as the log of the product of those quantities. So it looks something like this. We have the log, the sum base b of x plus the natural log of, say, some number y to that same base b. And here I'm assuming that x is positive and y is positive. I could put absolute values to guarantee that, but I'll just leave it like that. And this is the same thing as the log of the product of xy. To base b. So again, anytime you have the sum of two logs, that's the same thing as the log of the product of those same numbers, in this case x and y. So over here, in this one over here, I can rewrite this and using this property here as the natural log of this product. And I'm just going to put it in absolute values. I could try to separate, but again, I can multiply through absolute values. So this will be 1 plus cosine x times 1 minus cosine x. So that's going to be the difference in the sum of the same two terms. So it should be clear to you, I hope, that this is natural log of the absolute value of 1 minus cosine squared of x. So as I mentioned before, I picked the left side, and I want to show the left side simplifies to the right side in this case. So the right side is my objective. I want to get what I have over here. What do I have? 2 natural log of absolute value of sine of x. So over here I have 1 natural log, which is okay. Now I have 1 minus cosine squared of x. I want to wind up with sine. So again, I'm going to use the identity cosine squared of an angle. This is one of your fundamental identities, plus sine squared of the angle equals to 1. So you can see then, if I solve this fundamental identity for sine squared x, I would bring the cosine squared x to the other side, and that would tell me that sine squared of x is equal to 1 minus cosine squared, which is this right here. So I can just go ahead and replace this by the natural log. Then this then becomes the natural log of, instead of 1 minus cosine squared of x, this would just be sine squared of x. And that's the absolute values. Just from basic properties here of absolute values, I can rewrite this. Still looking at what I want to come up with. I can rewrite this as absolute value of sine of x and I can actually bring this exponent out here on the absolute values. And then using another property of logs. Okay, I'll write this over here. If you have the log of some number x to base b, and say this number x is taken to the r power, I can rewrite this as r times the log of x to base b. So this exponent there can become a coefficient. That's what that's saying. So over here I can do that. To complete this, I would just bring that 2 out in front and say this is the product then of 2 and the natural log of the absolute value of sine of x. And that completes the verification. So I used a fundamental identity, this cosine squared of x plus sine squared of x equal to 1, to make a substitution right there. And then over here, of course, I used the property of logs to write this sum of logs as a product. So that's how I got the 1 minus cosine squared of x. I multiplied the 1 plus cosine of x and the 1 minus cosine of x. And then to complete it, I used another property of logs right here that allows me to bring this exponent as a coefficient, and that confirms this identity. Clear this. So this one tells me that natural log of the absolute value of secant is equal to minus natural log of absolute value of cosine. So this one again doesn't really matter which side I use. They're pretty much the same. Normally you start with a more complicated side or more complex side. This will work either way. So let me just take the left side to start off with. And I would suggest you always write out completely the side you're working with. If you're working with the left side, write it out. If you're working with the right side, write it out, and then show how it simplifies to the other side. So I'm taking natural log of absolute value of secant of x. I want to come up with this. A couple of ways I could set it up here, but let me just do this. Secant of x, again using fundamental identities from trigonometry, secant of x is 1 over cosine of x. And that's of course what I want, because I got to look at the right side. I have a cosine there. And then I have a negative out in front. So how does that work? Well, I can do this. Natural log, just like if you have 1 over x, 1 over x by itself, using properties of negative exponents, that becomes x to the negative 1. Definition of a negative exponent. So I can rewrite this then as natural log. Let me just do it this way. Cosine of x. And I'll put that in parentheses to the negative 1. And then close the absolute values here. And just to make this clear, let me rewrite this as natural log of cosine of x. And this exponent here, I can put it just out here outside the absolute values. It's the same thing. And now I can use the property that I used earlier. If I have a natural log of some number to a power, I can take this power and put it out as a coefficient. So the negative 1 multiplies the log in front, becomes a coefficient. So I can put a minus 1 or just a minus as it is over here on this side. So this becomes natural log of the absolute value cosine of x. And we close the absolute value. And that confirms it. Now, in this case, the left and the right side are pretty even in terms of complexity. So it doesn't really matter. So if I start with the right side, I have a negative natural log of absolute cosine of x. Again, properties of logs, I can rewrite this. And this negative becomes an exponent right here. And this becomes a natural log then of, because of this negative, again, definition of a negative exponent, this becomes natural log of 1 over absolute value of cosine of x. And again, I could also write this as absolute value around this thing, and then 1 over cosine of x. All of it in between the absolute value signs. It's the same thing. And then I can say 1 over cosine of x that's the same thing as secant. So I can just rewrite this as secant of x, and then put it in absolute values, and that confirms it. So like I said, in some cases, the left and the right side are going to be pretty much similar in terms of complexity, so it doesn't really matter which one you select. Just go through the basic concepts that we went over. In this case, we're using fundamental identities, some properties of logs, properties of exponents. It's basic algebra. Thanks for watching. That'll be it for this video.